Hi there, welcome to FE Made Easy. Today we're going to solve a problem on retaining walls because why not? I wanted to add that if you are going for FE exam, I want to wish you good luck and come back here and let me know how it went. If you have a problem that stuck with you from the exam, I invite you to share it with me. Either leave it in the comment section below or send it via email at femadeeasy.com. Now let's get back to our problem for today. A retaining wall extends 3 meters from the top of bedrock to the ground surface. The soil is cohesionless and has the properties shown. Using the Rankine theory, the total active earth pressure per unit weight of retaining wall is most nearly. And the key word here is active earth pressure, which means we're going to have to calculate Ka. Let's go to FE Handbook and find the formula for Ka. We can either go to civil engineering, which is going to bring us straight to geotechnical and scroll down a bit. Or you can also do a search and do active earth pressure coefficient Ka, and this is the one I was talking about. So this is what we're going to have to calculate and use in our problem. So let's write the formula down. Ka is equal to tangent squared of 45 degrees minus phi over 2 equals 2 tangent squared 45 minus phi over 2. And I'm just going to go ahead and substitute squared 45 minus, and phi is 35 degrees over 2. And now we're going to use calculator, and I encourage you to do the same. It is important to get used to the calculator that you're going to have on the exam. So I'll have 35 to divided 45 minus, so 27.5, and now I'll do tangent of that and squared. So I get a value of 0.27. 0.27. So now that I have Ka, I can go back and talk about the earth pressure. I'm going to extend this line a little bit to draw our diagram here. So our problem actually is a lot simpler. We have only one type of soil. So the pressure is going to build up in the shape of a triangle. And we need this value over here. And based on FE Handbook, you're actually given the value over there. Let's go to the vertical stress. So in this example in the FE Handbook, you can see you have one type of soil. H1 is the unit weight is gamma 1, and H2, the unit weight is gamma 2. And gamma 2 is actually just saturated unit weight of this soil. In our case, we only have just one type of soil, so we're going to need this sigma over here, which is unit weight multiplied by the height. So this is exactly what we're going to do. Come back here. This green value, green line here, is sigma and is equal to unit weight multiplied by age. In our case, age is 3 meters. How about unit weight? Let's write down unit weight equals. In our problem, we are given the density, and this is I hope you are not going to get confused. What is the density and what is unit weight? The relation, I think this relation between the density and unit weight is given in the FE handbook somewhere. I'll take a look. But I want you to remember that this relation is that unit weight is equal to the density multiplied by g gravitational acceleration. And because if you use this value in the formulas, obviously you're going to get the wrong answer. So this is what we have to do. We're going to just take the density, which is 1,834, and these are kilograms over meters cubed, multiply by G, which is 9.81 meters over seconds squared. And let's see how much this unit weight is going to be. So I have 1,834, 9.81 multiplied. So I am getting 17,991.54. 991.54. And let's look at the units. So what I'm going to have, I know that kilograms multiplied by meters over seconds squared is actually newtons. So these units are going to be equal to newtons over meters cubed. So now we have units of unit weight. And we can move forward with this problem now. The resultant force for a triangle is going to be situated approximately somewhere here, but we know exactly where this is. So if I was to show the distances, this is 2/3 of the height, and this is 1/3 of the entire height. And this is P, the resultant force, and this resultant force, based on the FE handbook, if you go back here, the horizontal stress profile and forces. So P, again, we're going to look at this example over here because we have only one type of soil, and the resultant force equals to 1/2 because it's a triangle, multiplied by the base, which is sigma, multiplied by the height, H1, and multiplied by this active earth pressure coefficient, Ka. So let's go ahead and write this down. We're going to have that P, actually I'm going to write it down here, P is equal to 1/2 multiplied by sigma, which is this value over here. I'm going to write down sigma multiplied by now the height, right? And multiplied by Ka. And now let's go ahead and substitute everything. I have 1/2 multiplied by sigma, which is gamma multiplied by the height. So this value here is sigma. And now I'm going to move forward. We have multiplied by height again and multiplied by Ka. So now I'm going to go here and substitute 1/2. Let's see, gamma equals to, we have 17,991.54 newtons over meters cubed, multiplied by the height, which is 3 meters. And then we have the height again. Oh, for some reason, this pen doesn't really help me today. Okay, multiplied by the active earth pressure coefficient, which is 0.27 equals. Let's use the calculators again and let's see how much is this. 2 divided, 3 multiplied, 3 multiplied, and then 0.27 multiplied. So I get a value of 21,859.72, and these are, let me build this, newtons over meters. So I have newtons over meter. And in the options given here, A, B, C, D, the results are in kilonewtons. So all I have to do is just divide this by 1,000. So if I divide this, let's say if I divide it by 1,000, I'm going to get that the active earth pressure is equal to 21.9 kilonewtons over meters, which is approximately 22. So the correct answer is A. There you go. We can also write this down, 22 kilonewtons over meters. An important thing to remember is not to use density or to be able to understand what is the difference between density and unit weight, or what is the relation between the density and unit weight, and then you can use the right term in your calculations. I hope this was helpful to you. If you have any questions, please leave your comments in the comment section below. And don't forget to subscribe because this helps put this video in front of more people just like you. I know I am like a broken record, but in order to be able to go on the exam confidently, you have to solve as many problems as you can. So do that, and I will see you next week.